Greetings once again, awesome learners, and welcome to another edition. In this edition, we are beginning our practice problems. Our practice problems, they come from past papers, and our focus will still be on arithmetic sequences. So the first batch of our problems will be mostly based on November exams. Then the second batch will be based on May and June exams. So let's have a look at the first question, which is going to be problem 1 of our practice problem. And problem 1 comes from Maths paper 1, which is the November 2024 paper. And this is question 2 on that paper. And the statement reads, the first term of an arithmetic sequence is 7. The common difference of the series is 5, and the series contains 20 terms. And the first question, 2.1.1, requires us to calculate the sum of the series. So what we need to note, let's go and make note 2.1.1, is that we are given the first term to be 7, and we know for an arithmetic sequence, our first term is always equal to A. And then we are also given that the difference, D, is equal to 5. And what we are also told is that we have n is 20. And n is 20, remember, it is the number of terms. So this means we are in a position now to go and calculate the series, because we know the formula for an arithmetic series, so we know the sum. So our sum of an arithmetic sequence as n is always given by, we can either use n over 2 into 2 times a plus n minus 1 multiplied by d. We already have n, we already have a, we already have d, so we can go ahead and find the sum of 20 terms. And this is just going to be 20 over 2 into 2 times a, our a is 7, and then plus we have 20 terms minus 1 times our difference, or the common difference, was given as 5. So this is going to be multiplied by 5. So S20 will be equal to, so I'm going to go to my calculator, punch this and come and give us the answer. So the answer which we obtain, if you go and use your calculator, you should be able to see that we will find 1090. Okay? So we are done with the first question. So let's go for the second one, 2.1.2. So 2.1.2 requires us to use our understanding of the sigma notation. So let's read the question. So the question reads, the original arithmetic series, which was 20 terms, is extended to 75 terms. The sum of these 75 terms is 14,400. Use sigma notation to write an equation for the sum of the added terms to the original series. So this is very important for us to understand. So essentially we now have a series which has what you call it 75 terms. So n is 75, and what we are given is the sum of 75 terms. The sum of 75 terms is 14,400. But remember that what we had initially was actually the sum of 20 terms, of which the sum of 20 terms we found as 10, 19, 90. So if you think of what is happening here, we can actually find what is the sum that we added from as 20 for us to eventually get the total sum. So if you think carefully, for us to get the sum of 75 terms, what we had was the sum of 20 terms, and then plus the sum of the terms from term 21 up until we get to term 75. That is what happened. So if you sum the terms from 20, and then you add it with the sum from 21 to 75, you get the sum of 75 terms. Which means, in other words, we can get what is the sum when we start from term 21 up until term 75. And how we are going to get that is the sum of 75 terms minus the sum of the first 20 terms. And if you observe carefully, this just becomes 14,400 minus our 1090. So essentially the sum of terms from term 21 up until term 75 will be equal to, it will be equal to 13,310. Why is this important? They said we should write down an equation for the sum of the terms added to the original series. So if you look carefully, this here is the original series. And this one here in blue, these are the added terms on top of the original series, which is why we needed to find what is the sum of these added terms to the original series, which we found 13,310. So what we can now go and do is we can go and express this in sigma notation. So if you think carefully of what is happening is, for sigma notation, remember, we need to know which term are we starting on. So according to our problem, we clearly should start from term 21. Okay, then we are going to end on term 75, but here we need our general formula or our general term, which we have not found, but we know that this will be equal to 13,310. So now the question which we need to ask ourselves is, what is our general term? And finding the general term is extremely easy because we already have our A. So the first term is 7 and the difference is given as 5. So we can go ahead and find our Tn, which will be A plus n minus 1 multiplied by D, of which this will just be A plus, or let's put in the 7, it will be 7 plus n minus 1 times 5. So if you quickly work out your Tn, you will see that it will be 5n plus 2. But remember, whenever we are using the sigma notation, we always replace k or n with k. So our answer will be as follows. Our answer in sigma notation will be our sigma sign, and we are going to start from k is 21 up until we get to 75. And then our general term is 5k plus 2, and the sum will be 13,310. So this is what we are required to do. So make sure you understand the principles of this question, and you should be able to answer it easily. Cheers. Next, we'll have a look at the next question.